Okay, so 3.5 lecture homework, question number 1. It's saying f of x is x cubed plus 2. So what does it do? What does it do to a function, to a graph, when you add and subtract different numbers here and there? What does that actually do? Well, let me be clear and helpful to you on this. Basically, if you take, first off, what is the graph y equals x cubed look like? I don't know if you remember back from the notes. Here, let me go to the notes with you real quick. From the exam 1 notes, find them. We already have a bunch of the graphs already there for us. Somewhere down, I think. There they are. Yeah, so there they all, a bunch of them are for us. There we go. Okay, so there's a bunch of them. You see y equals x cubed right here. It's a snake. I call it the snake graph. See, it goes like this. Snakes on through. That's x cubed. That's cubic. So you can put this on your notes for exam number 1. Be a good idea. You'll have all these ready to go for yourself. Okay, so that means the graph of x cubed is basically this kind of snaky thing. And it goes right through the origin. Notice how all the graphs go right through the middle of the graph, the origin, don't they? See how they do that? The center. Now, even this one right here, he doesn't touch the middle, but that's still the center. This one too. The middle is still the center of the graph. So for all the graphs, the center is the origin. But now we're going to add numbers and subtract numbers and multiply numbers and divide numbers. And it's going to move these graphs around. It's going to stretch them. When you put negatives in there, it's going to flip them. So we're going to learn about how graphs move when you do different things. So first off, what happens if you add 2? Well, I bet you can guess. Y equals x cubed plus 2. What that will do, that will move, it will add 2 to all the y values. And graphically, the graph will move up 2. The graph will move up 2. Now you might think, you might look at this and go, no, what do you mean add y values? It's adding over here to the x. No, it's technically not. Look at number 2 here. That's what it means to add 2 to x. Yeah, maybe it'd be good if I did number 2 at the same time. Let me do both these at the same time. Yeah, so let me just come on down to number 2. It's good to have them both. I think it makes more sense that way. So on number 2, we have y equals, or f of x, whatever, same thing. There's no difference between y and f of x. It's all the same thing. Equals x, and then the plus 2 is in here. What cubed, huh? It's the same exact function. Yeah, see the difference? Now this one, it adds 2 to the x values. See how it's adding 2 to all the x values? Right there. And on the graph, it'll move the graph. Now this might be a surprise, left 2. You might have thought, right, adding 2 will actually make it go to the right. No, it'll actually go to the left. It's backwards. So you see the difference first off. If you add 2 outside of the x, after the x to the 3rd power thing, it's actually adding to the y values. It's what we call a y effector. It's what I call it. I say it's affecting the y. Whereas if it's in the parentheses, right next to x, it's going to be an x effector. So that's really important to put in your notes. Make sure you're clear on that difference. So this is an x effector when it's in the parentheses next to x. This is a y effector when it comes after the x to the third power. That makes a difference. So let me go back and actually do the ones in the homework here and show you what we're looking at. Yeah, and I'll explain why it moves left instead of right. That's a great question. Let me look here at number 1 with you. So this one, like I was saying, this one is going to add 2 to all the y values, not the x values. In fact, I'll just click this. It would add 2 to all the y values. Right. And then what effects it can have on the graph? It would shift all the points up 2. That's what we talked about. All those points are going to go up 2. This plus 2 out here is going to move everything up 2 because it added 2 to all the y values. It's not because it's not in the parentheses next to x. That's the only way to add to an x value is to be in the parentheses next to x. It's not for this one. All right. And then number 2, here's number 2. This one has a 5. What is that 5 doing? Well, that one's in the parentheses. So that's going to, it's going to affect the x. It's going to add 5 to the x values. Now, what is the plus 5 going to do? It's actually going to go left 5. Left 5. We would think, well, right, shouldn't it be right? I'm going to explain that in just a second. I just wanted to show you that is the case in the homework. Okay, let's go back to the iPad. And I'll finish writing out the details of this one. As soon as it connects here for us. There we go. All right, so yeah, so it's just like I wrote out here. Again, if it's after the x, outside of the x in the power, it's actually having a y effect. It's not having an x effect. It's not in x's little world. It's kind of like the old saying, you know, to understand somebody, you got to walk a mile in their shoes. You know, it's not a bad saying. So this guy down here, this one is in x's shoes. He's living inside on number 2. On number 2, this guy's living in x's world. So he adds to the x values, whereas this guy is not. He's kind of outside of x's world. So he's a y effector. He really has a y effect. Now, what about the left instead of right stuff? That's a great question. Why does adding, so you might be thinking right now, I assume you're thinking right now, okay, I get it, Miss Sharon, I get it. It's in the parentheses, it adds 2 to the next place. But why isn't that right 2? I mean, isn't adding stuff to the right and negative to the left? And, you know, positive is up and negative is down. Yeah, but it's reverse for x. So you want to remember, yeah, adding 2 on the x, I'm sorry, on the y, does move it up 2. So that's normal. That's like what you'd expect. But x has the opposite, and I'm going to give you a reason why, but let me first say the fact. X has the opposite effect. X stuff, when you add to the x values or subtract, it always has the opposite effect. Adding to x is actually left. Subtracting from x actually goes to the right, which is totally the opposite of what we would normally think. Adding to x actually goes left and subtracting goes right. It's backwards. Why? Why is it backwards? Well, it's a little technical, but let me make an effort to describe it to you. So if you take this function, let me bring it down here, x plus 2 cubed, keep writing that, cubed. And let's compare it to just the normal x cubed, right? The normal x cubed, and we know the graph. Smaller. We know the graph for the normal x cubed over here. The normal x cubed graph does his snake thing. Oh, it wasn't so good. It's on the wrong two. There we go. Does his snake, goes right through the origin, right? If I put in 0 for x, y is 0 because 0 cubed is 0, right? Well, how about over here? What about the graph over here? What's this one going to look like? If I put a, what do I got to do to make y 0? What do I got to plug in for x to make y 0? Can you see it? -2. Huh? If you put in -2 for x, y is 0. That means back 2, up 0. That's the point. Back 2, up 0. Do you see what it's done to the graph? Do you see that? It's shifted it, hasn't it? Do you see how it's moved it back 2? Because you got to plug in -2 here to get y 0. It shifted it from 0, 0 back to -2, 0. So it has this adding +2 right here actually shifted it left 2. X plus 2 has a left 2 effect on the graph, doesn't it? See, it's just simply true. It's just simply true. So you got to remember it. X has the opposite effect on graphs. Yeah, glad to help, Kristen. So yeah, so there we go. And by the way, if I did the y, it wouldn't have an opposite effect. Here, let me do the y just to show you. Y has the normal effect you'd expect. So let me go back to the y equals x cubed. Well, in fact, you know what I could do? Well, maybe let me just do that. That'll be easy. So I'll just come down here. And I'm just going to do the y equals x cubed plus 2. So again, if you imagine making the xy table and you plug in 0 for x, plug in 0 there, what are you going to get? 2 for y. Over 0, there's the point, over 0 up 2. So sure enough, see how it moved the graph up 2. So adding 2 to y has what we would expect, the normal effect we would expect. It moves the graph up 2. You can see it right there as you make that table. Whereas adding 2 to x, this one right here, actually you can tell moved it left 2, like that. All right, so remember then, you have to remember it's not just for this graph, it's for all the graphs. It's a graphing principle. What is? That x has the opposite effect. Adding to x makes you go left, subtracting from x makes you go right. Whereas y, let me write up here for you, y has the normal effect. Y has the normal effect. If you add to y, the graph goes up. Making it worse by scribbling it. If you add to y, the graph goes up. If you subtract from y, the graph goes down like you would normally expect. So y, whatever you do with y has a normal effect. Whatever you do with x has an opposite effect because of what I just showed you. So there we go for 1 and 2.